Welcome back. Let's continue our discussion of proportions and determining whether data is proportional. So we've already discussed the need to have equivalent ratios if we have a proportion. Today we're going to talk and focus more on the visual representations in tables and graphs. So in order to be proportional, the graph has to be a line that goes through the origin, and the data has to show a constant rate of change. It also needs to have equivalent ratios, which we already discussed. So you're on the same notes, note 17, proportions and determining proportionality. This time we're on example 3. So this first example is just showing you some different visual representations. So we have this table over here showing a comparison of time to height. And now the graph is over here of that data set. So the table and the graph are representing the same data set. So we have time on the x-axis, time. We have height in meters on the y-axis and height in meters. So what we have here from the table is ordered pairs. This is 3, 2. So this is 3, 2. The next point, 6, 4, 6, 4, 9, 6, and 12, 8. So a couple of things that we want to check to determine if the data shows a proportional relationship. Number one, when you graph it, is it a line that goes through the origin? Well, if I plot these points, they form a straight line. Now the question is, does it go through the origin? 0, 0. Well, 0, 0 is not in the data table, but we do see that there is a constant rate of change. So we see time is increasing by 3 seconds and height, consequently, is increasing by 2 meters. So what we want to do to determine if 0, 0 is part of this data set is we'll apply that same pattern backwards. So we would subtract 2, and that would put us at 0. And we would apply the same pattern backwards, subtracting 3, and that gives us 0. So that does make the data set true. So the line is a graph through the origin. We see we have equivalent ratios here. So if we're comparing y to x or x to y, we have 3 to 2. 6/4 also simplifies to that same ratio, right? We could divide by 2, and we get 3 to 2 again. Divide by 3, we get 3. Divide by 2, divide by 3, we get 2. So we're at 3 to 2, 3 to 2, 3 and 2. And same thing here, we could divide by 4, and we'll end up with those equivalent ratios once again. So this data is a line through the origin. The data shows a constant rate of change, right? We have a constant rate of change going on here. And we have equivalent ratios, the 3 to 2. So this data is proportional. So now we're going to go through a couple of examples to determine if the visual representations of our data is proportional. So use the graph or table to determine whether the data shows a proportional relationship between x and y, right proportional or not proportional, and explain your answer. So first I'm looking at this graph here on the left. What I could do is I could start by, nope. Let's see what's going on here. Give me 1 second. Okay. Hopefully that fixed the issue. Yeah. So I could write out my XY table and write down my data. Well, what is this point right here? 0, 4, then 2, 6, then 4, 8, and then 6, 10. Well, the first thing I notice, the first thing I notice is that this point is not 0, 0, it's 0, 4. So right away, it's not proportional. Because the graph does not go through the origin. And that's enough. But we could prove it even more. If I simplify 2/6, I get 1/3. If I simplify 4/8, 4 goes into 4 once, 4 goes into 8 twice. 1/3 is not equivalent to 1/2, so we don't have equivalent ratios. We also don't have a constant rate of change, right? This is increasing by 2. Well, actually, let me rephrase. We do have a constant rate of change because it is a straight line, but it has to meet all the qualifications. It has to have 0, 0, equivalent ratios, and the constant rate of change. So it does have the constant rate of change, but that is not enough. So we are not proportional. So let's take a look at B. So here I'm looking, okay, I have my table. It doesn't have that 0, 0 on my data set, so I have to determine it. So I might start by looking, is there a constant rate of change? I see this is increasing by 1, this is increasing by 1, this is increasing by 2, this is increasing by 2. That sure looks like a constant rate of change to me. So it has a constant rate of change. So that's good. Now, if we were to apply that pattern backwards, we would subtract the 1 and we would be at 0. Here we would subtract the 2 and we'd be at 0. So is 0, 0 part of the data set? It is. So it contains 0, 0. And then we want to check our equivalent ratios. So we have 1/2. If we divide, we would have 1/2. And if we divide, we would have 1/2. So do we have equivalent ratios? We do. Equivalent ratios. So it meets all the qualifications to be proportional. Let's look a little bit more. So the data in the table below is proportional. So it's telling us right now it's proportional. And our job this time is to fill in the missing data values in the table to maintain the proportional relationship. So if it tells you that it's proportional, what point must be part of the data set? Did you say 0, 0? You'd be right. Now, I don't see that data point here, but I could put it in. And again, I know that these are equivalent because they're proportional. So each of these ratios have to be equal. I also know that there has to be a constant rate of change. So this is going to be +1, +1. And then I see, though, that that's going to be +2. Something to think about. Well, what's the rate of change here? +8, +8. And then we don't know because we have a blank. So what I want you to look at is a couple of things. First, could we figure out how much somebody makes per hour? Remember, the unit rate is when we have a denominator of 1. And so we're comparing, do we say hours per money earned or money earned per hour? We say money earned per hour. So we would write our labels like this. And if we look, we have $8 earned in how many hours? 1. So this is our unit rate. So we earn $8 per hour. So we're trying to keep that same ratio. So we see 8 to 1, 8 to 1. And so what we have to do is make this value so that when we simplify it by dividing by 2, it maintains that 8 to 1. So what divided by 2 is 8? 16, right? So now if we divide 16 by 2, we still have that ratio of 8 to 1. So then 16 plus 16 would make this 32. Let's try again. So now, what is this distance? What's that rate of change? So we have 56 minus 32. So this is plus 24. Now we know that ratio needs to stay 8 to 1, 8 to 1, because this is our unit rate, right? So we need some value that when we divide 24 by it, it retains that value of 8 to 1. What would it be? Plus 3, exactly, because 24 divided by 3 would give you that 8 to 1 ratio. So then 4 plus 3 is 7. And so now we have filled in our table. Let's take a look at another visual representation. The graph of a proportional relationship passes through the points 4, 8, and 1y. What is the value of y? So let's take a quick look. So this is x, and this is y. So what points do we know? Well, we know 4, 8, so let's plot 4, 8. And it tells us again, this is proportional. Let me ask you again, what point must be on this graph if it's proportional? Did you say 0, 0? There it is. Now 1y is what we're trying to figure out. So if I draw this line in and connect these 2 points, right? It looks like that point is somewhere around this area, but we can't be sure all the time, so we have to prove it. So let's make our table, x, y. We know we have 0, 0. We know we have 1 and some value y, and we know we have 4, 8. Well, I know that in a proportional relationship, my ratios have to be equivalent. So I know that these two have to be equal to each other. Can we use proportional relationships to figure out what that might be? Well, let's look. How do I get from 4 to 1? Excuse me. We would divide by 4, right? So what would y be in this case? Y would equal 2. And if we look, 1, 2 is right here, which is pretty close to our line. Maybe your line was even closer than my line was. We could prove this using cross products as well. If we had 1 compared to y and 4 compared to 8, if we use cross products, we have 1 times 8, and that's equal to 4 times y. So we have 8 equals 4y, divide by 4, and so once again, 2 equals y. So here we use proportional relationships, here we use cross products. Now let's take a look more in depth at graphs. So we want to be able to read the data on graphs. So this particular graph is about a rover. And so we're interpreting each point. So we see here that at 0, 0, the rover's traveling 0 inches in 0 seconds. That makes sense. Now this point here is our unit rate. Whenever x is 1, that's our unit rate. So this point here is our unit rate, which is telling us that the rover travels 1.5 inches in 1 second. So that's our unit rate. And then we have another proportional data point here. Interpret each plotted point in the graph of the proportional relationship. What is the coordinate of the unit rate and what does it mean? So what is this graph about? It's about chicken. It's about cost or price per pound. So let's start with 0, 0. What does this one mean? Well, it costs $0 for 0 pounds of chicken, right? It's not going to cost me anything if I don't buy anything. The next point we have is 312. What does 312 mean? Well, if I look, I see that here's the 3 on the x-axis referring to pounds, and here's the 12. So that means it costs $12 for 3 pounds of, chicken. What does 520 mean? Good job. It costs $20 for 5 pounds of chicken. So we've now interpreted each plotted point, but we also have to figure out the coordinate of the unit rate. Well, a couple of ways to do this. One, you could look at the graph, but the graphs aren't always super accurate. and my computer has stopped working. Not sure why, but I can't seem to write. So what we could also do is write out a ratio. Let me see if I can flip my computer around here. Nope, pen's still not working, so let's type. So we have cost per pound. And we could write out our ratio, right? So we have cost 12 per pound. There should be a line in between those two. And if we divide both by 3, we'll see that we have 4 to 1. So our unit rate or our cost is 0.14, which means it costs $4 per pound of chicken. So we figured out our unit rate. And that does look like that point on the graph, but we want to prove it. Okay. All right. Now, I'd like you to go to journal pages 93 and 94. On journal page 93, it says use a graph to tell whether X and Y are in a proportional relationship, but you don't need to do that. Use the example on the first page to figure out whether there's a constant rate of change, equivalent ratios, and whether the data goes through 0, 0. So do that for 1 and 3. And then on 5 and 7, you're going to interpret each plotted point, and you're going to tell me what the unit rate is. Some graphs might give you the unit rate, and some might not. So you might have to set up a proportion or a ratio to figure out what that is. Give them a try. See you next time.